Okay, good day everyone. Sir John here, and welcome back to another discussion in the subject chemistry. For today, we are going to talk about the acids and bases. Specifically, at the end of this discussion, you are expected to understand the acids and bases in terms of Arrhenius theory and Brønsted-Lowry theory. And also, we're going to emphasize on the amphiprotic molecules and the pH concept. Okay, so for now, please get your ball pen and your notebook for you to take down notes on the important details that we are going to mention during our discussion today. So, I hope that you're doing well at your respective areas right now. Okay, wherever you are right now, I do hope that you are doing well. All right. For my students, please comment your complete name and your course and section to confirm your attendance. Again, for my students, please comment your complete name and section to confirm your attendance. So I'll be monitoring your attendance, and only those students who comment, okay, their name and their um, section during this particular time will be recorded as present. Katong mga late na, okay, late 15 minutes. So it's 9 uh, at this right time, okay, kung late ka, so that means late pud di mo hang attendance. O ugma na pud ka mo comment, that means absent ka. Okay, that's just a um, simple instruction to follow. All right, so let's proceed. So we have here the acid base concept. So what is an acid and what is a base? Okay, acids and bases are chemical opposites. When you say opposites, they have different properties. Okay, so they react to neutralize each other. So mura ni siya og tamis og pait. Okay, okay, isagol siya ma-neutralize ang iyahang lasa. Okay, so it's like that. So they neutralize if they react to each other. Kung imong isagol si acid o si base. Okay, at the heart of the reaction is a tug of war for protons or the hydrogen ion. So, in this concept, okay, if we try to look at this concept, all we can see here, okay, is the transfer, the moving of protons. Okay, the moving of protons, okay, basically from hydrogen ions. Okay, kay mostly si hydrogen may mohatag og um, charge, okay, to form the conjugate acid and bases. Later on, you will know about those concepts. Okay, but take note that at the heart of this reaction is the transfer of protons. Okay, next, acid-base chemistry has many applications. Okay, that's why it's a very significant. Okay, it's really important, especially in your course. Okay, to really study or have knowledge about acid and bases because it has a uh, application. It has an application in our different areas sa ato ang life. Okay, we have food industry, cleaning, living systems, environment, cosmetics. Okay, it's really important to understand these concepts. Why? Because the properties of a particular substance would also reflect or relate to its use. Okay, lahi ang use sa basic nga mga gamit or substance, lahi po ang use sa mga acidic nga mga substance. Okay, so I hope that's clear. All right, next. I have here examples of common acids and bases. For acid, we have citric acid, okay, which is commonly found in citrus fruits or kanang mga aslom na mga prutas. We also have ascorbic acid, okay, also known as vitamin C, acetic acid, vinegar, carbonic acid for carbonation of soft drinks. Okay, kanang mga soft drinks na to na may carbonic acid. We have lactic acid in buttermilk, sulfuric acid in car batteries, and hydrochloric acid in stomach. All right, so naay acid ha, ato ang stomach naay acid. If you want to know more about the details of hydrochloric acid in our stomach, I have a separate video for that. If you want to check it out, you can look for that at the shorts, kanang shorts na section sa ani nga YouTube. Okay, if you want to look at the property of the acid sa ato ang stomach, okay, it's available there. It's just a short video. All right. So those were the examples of acids. Let's proceed to bases. Okay. So for bases, we have detergents, soap, Toms or magnesium carbonate, sodium hydroxide, household ammonia, baking soda, or sodium bicarbonate. So these were just some of the example of bases. So we frequently use this, okay, substances every day, almost every day. Kaning sabon, okay, without knowing base nila siya. So you will basically know, okay, from this lesson, okay, how these different things came to exist. Okay, so next we have also properties of acids and bases. So let's talk about the properties of acids first. Okay, for acids, commonly they taste sour. Okay, the word acid comes from the Latin word acere, which means sour. Okay, aslom siya. And acids also change litmus, okay, a blue vegetable dye, from blue to red. So meaning to say, if you are going to test, okay, whether, okay, when you place a litmus dye or litmus uh, paper to that solution, okay, so the litmus paper will turn to red. Okay, ma-red siya. And that indicates acidic ang usa ka substance. Next is their aqueous water solutions conduct electric current. Okay, meaning to say, acids are electrolytes. It allows the flow of electric current. Okay, acids also reacts with bases to form salts and water. Meaning to say, when you combine acid and base, okay, you can have salt and water as the product. Okay, it also evolved hydrogen upon reaction with an active metal such as alkali metal and alkaline earth metals, particularly like zinc and aluminum. Okay, so let's proceed to the properties of bases. Okay, unsa man ning mga bases. Okay, so bases taste bitter. Okay, pait siya. It when you try to touch it or to feel it, okay, it feels slippery or soapy. Kanang dangog siya. Yung sabon, yung shampoo. Okay, most of that is basic. Okay, those are bases mostly. Okay, so when you feel their texture, they are foamy, they are slippery, they are soapy. Okay, bases do not change color of litmus. Okay, they can just turn red litmus back to blue. Okay, ang indication ra gyud kung mogamit ka og litmus, okay, kung mo red siya, that means acid. Kung dili mo change ang color, that means base siya. Okay. Excuse me. All right. So their aqueous water solutions conduct an electric electric current. They are also electrolytes, conduct an electric current. Okay, just like the acids. Next is it reacts with acids to form salts and water. Okay, you combine siya sa acid, okay, maka-form gyapon siya og salt and water. Okay, those are the different properties of bases. All right, so I hope that you've taken down notes about that. Next, okay, so I have here an image showing us, okay, the litmus paper. So ingani porma if we are going to test a substance. O kani siya, this one, okay, this is the litmus paper. And then if when you will put it or submerge it into a solution nga acidic, so ang imuhang makit-an sa area nga na-submerge sa solution is red. So it means the blue litmus turns to red. All right. So on the other hand, if kani siya imuha na po ning ibutang sa basic nga solution or base nga solution, it will turn to blue again. Mabalik siya sa pagka-blue. The red litmus turns to blue. Okay, nga na siya. Alright. This time, let's talk about the Arrhenius theory. Okay, Arrhenius principle about acids and bases. Okay, so the Arrhenius theory, okay, is one of the earliest and the simplest definition of acids and bases, which was promulgated by Svant Arrhenius. Okay, the spelling sa Svant is Svante. Okay, Arrhenius, and that was in 1884. Okay, and then he describes acids and bases based on their behavior in water, meaning to say it's Mr. Arrhenius look at this the property of acids and bases in aqueous form. Okay, aqueous solution. Okay, nga na ang kang Arrhenius. So according to him, acids release hydrogen ions in aqueous solutions. Ang inyong timan-an, basta acid mo release og hydrogen ion. And if it's a base, okay, it release a hydroxide ion in aqueous solution. Kung kani siya may hydrogen ion, kani siya may hydroxide ion. All right. So water required so only allows for aqueous solutions. So kinahanglan according to Arrhenius maka-identify siya if acid or base siya as long as it is an aqueous solution. Only protic acid are allowed, required to release hydrogen ions. So if acid siya, it must be a protic. Okay, when we say protic, that means it must give a proton. It must have the capacity or the property of giving a proton. Okay, mo donate siya og proton. Mo na ipasabot sa protic. However, if it's a base or basic siya, dapat muhatag siya, mo release siya og hydroxide. Okay, mo allow siya og release sa hydroxide. So basically, when you try to look at the acids and bases, okay, in Arrhenius theory, makaingon ka kung acid siya basta naay hydrogen ion, ya makaingon po ka og base siya basta naay hydroxide ion or OH. Let's have this example. Okay, so we have here kani hydrochloric acid and sulfuric acid. So when we try to look at these compounds, kay naa siya'y hydrogen ions. So meaning to say, mo na acid. O sa base, we have sodium hydroxide. O kini siya, when we try to look at this compound, compounds, okay, naa siya'y hydroxide or OH. So that is just, okay, the indication of Arrhenius. Well, of course, always put in your mind that for Arrhenius, okay, it is all about the aqueous solutions. Ang Iyahara is all about the aqueous solution. So this time, let's proceed to the Brønsted-Lowry acid-base model. Kikinsa naman po ni si Brønsted-Lowry. Okay. So the Brønsted-Lowry is a development of the Arrhenius theory. Mura ni siya og um, improvement of the theory ni Arrhenius. It was promulgated or created in 1923 by Mr. Johannes Nicholas Brønsted, Johannes Nicholas Brønsted, and Thomas Lowry. Kikinsay nag-create ani si Johannes Nicholas Brønsted and Martin Lowry. Okay. So, according to their model or theory, an acid is a proton donor and the base is proton acceptor. So meaning to say, in in their theory, they are mostly emphasizing on the transfer of electrons rather than, okay, the property of acid and base in aqueous form or aqueous solution. So meaning to say, it is not restricted only to aqueous solutions, just like sa kang Arrhenius. Kaya nga naman, there's a limitation of the theory of Arrhenius. Kay maka-identify ra siya sa acid and base if aqueous siya. How about those compound nga dili aqueous like the ammonium, okay? Like the ammonia in NH3, which is non-aqueous. Okay. So this compound is non-aqueous and it it did not release a hydroxide ion. So dili siya maka-explain anha nga compound. So meaning there's a limitation on the explanation of Arrhenius theory. And that's why na-form ang Brønsted-Lowry acid-base model, which will fix that discrepancy. Okay, kaya nag-focus naman siya sa transfer of protons. Okay, so in acid and base reaction, okay, the proton is transferred from an acid to a base. So meaning to say, according to Brønsted-Lowry, si acid ang maghatag sa proton and then si base ang magdawat. Okay, again, si acid ang maghatag and then si base ang magdawat. Okay, I hope that's clear. Let's have this kanang example. Okay, so we have here a hydrogen and an element B, okay, which reacts with A, which is also aqueous. So kani siya mo ni acid, kani maoy base. So pag gihatag si hydrogen kani gihatag ni A, so it forms kani HA, which is a conjugate acid. Okay? And then ang nabilin kani si B minus kay kini si H or si hydrogen gihatag naman. So ang nabilin atong ibutang dire. Okay. So HB and HA are Brønsted acids. So kani sila pareha ni nga acids. Okay, kani siyang conjugate acid, kari acid. Okay. And then A minus and B minus are Brønsted bases. Okay. All right, I hope that's clear. Okay, don't worry because later on in this session, we can have a lot of examples about that. All right. So, but the concept for Brønsted-Lowry is all about the transfer of protons. Okay, the transfer of protons. Okay, next, conjugate acids and bases. Okay, once an acid has given up proton, the remaining part can be a proton acceptor and thus a base. Okay, take note nga ang remaining part mahimong proton acceptor. So, do not forget nga in most cases, not in most but in all cases, si acid ang mo hatag og proton. And then kitsay mo dawat sa proton si base. Pero inig mahumana og hatag si acid og proton, ang nabilin mahimong base. Okay, take note ha. Inig mahuman og hatag si acid og proton, ang nabilin mahimong base. Okay. So once a base has accepted proton, it can release it again and act as an acid. So kung kadtong nabilin, mudawat na pud siya og proton, kay maadan siya og hydrogen ion, mahimo na pud siyang acid. Okay, and that's what we call as conjugate acid-base pairs. Okay, let's have an example. This one is a conjugate acid. So, conjugate acid siya. Ug mingon tag conjugate acid, meaning to say, ning dawat na siya og ni dawat siya og hydrogen. That's why in its form, in its formula, you can see hydrogen. You can see hydrogen. Pero kung mo release na po ni siya og hydrogen, kinsay nabilin? Mabilin si fluorine, F. So ang nabilin tawgon nato og conjugate base. Okay? And the same principle applies to this next compound. Okay, we have here hydrogen sulfate. O kani siya. Kinasi ning gikan ni siya ning dawat og hydrogen. Okay? And then mao na nga nahimo siyang conjugate acid. Pero og mo-release na pud ni siya og hydrogen, mabilin si sulfate. Okay, mabilin si sulfate. Alright. So, nga na siya. Nya kanipod si ammonium, okay, si ammonium kay di ba upat ang iyahang hydrogen. So, ug mo-release siya, nahimo ng tulo. Okay, and that is called conjugate base. Okay. All right. Next. Okay, for you to understand, okay, really about the reaction, let's have this one example. We have here hydrochloric acid, which reacts with ammonia, forming ammonium and a chloride. Okay, so as you can see here, this is an acid na siya hydrogen, kani siya maoy base. So ang nahitabo pag react niya, so ning release ni si hydrochloric acid og hydrogen. So asa ni dong si hydrogen? Anhi ni ammonia. So unsay nahitabo ni ammonia? Ang tulo ka hydrogen nahimong upat. Mao na nga from NH3 nahimo siyang NH4. Okay. So after that na ay nabilin kay nakuhaan man ni si hydrochloric acid og hydrogen, nabilin si chlorine. Mo na nga naa kay chloride are. Na kay chloride, which is an ion. Okay, did you get that explanation? I hope that's clear. So, kani siya mao si acid, kani siya mao si base. So, si acid mao ni hatag, si base mao ni dawat. So, pag humaniyag dawat, you can have NH4. Nya ang nabilin, you can have chloride which is an ion. Okay. So, kani si NH4, kaning nidawat tawgon siya og conjugate acid. Ang nabilin tawgon og conjugate base. Okay, the same explanation applies to this. Okay, we have acetic acid which reacts with water, okay, forming hydronium ion and acetate. Okay, so si acetic acid nihatag og hydrogen ani ni water. So ang duha ka hydrogen nahimong tulo, forming hydronium. Okay, so ang nabilin acetate kay wa naman ni si H kanina si C2H3O2 mao ni siya acetate ion. So ang ning dawat conjugate acid, ang nabilin conjugate base. I hope nga clear na siya. Okay, next. Okay, we have the amphiprotic molecules. What is an amphiprotic molecules? When we say amphiprotic, this pertains to the species that can either accept or donate a proton. Diba? In acid-base concept, it's all about the transfer of protons. Okay, so kung mayroon tag amphiprotic, a certain substance is able to accept or donate a proton. Murag duha iyahang capacity or duha ang iyahang ability. Okay, pwede siya mo accept, pwede po siya mo donate. Okay, so water is an important example to that. Water is amphiprotic, meaning to say it can release a proton and it can also accept a proton. Okay, so when the water molecule, look at this illustration. So kani mao ni water molecule. Okay, we have here Lewis structural formula. Okay, so kung mo release siya og proton, makuhaan siya og isa ka proton kay maka-form ka og hydroxide ion. Pero kung si water madugangan kay og proton, you can have hydronium ion. And not every compound is capable to that kanang activity. Okay, only those who are amphiprotic. Okay, and water is one of them. So again, kung makuhaan si water molecule og isa ka proton, okay, it can form hydroxide ion. Pero kung madugangan, it can form hydronium ion. Okay. Next. All right, so we have here the conjugate acid base pair. I mean pairs. All right, so this time I want to emphasize that the stronger the acid, the weaker the conjugate base, and vice versa. Again, the stronger the acid, the weaker the conjugate base, and vice versa. So meaning kung isog siya nga acid, kung after siya mo release og hydrogen, ang nabilin is weak nga base. Okay, and that's called a conjugate base. Again, kung isog siya nga acid, unya mo release siya og hydrogen or proton, ang nabilin is weak nga conjugate base. Okay, let's have this illustration here. Let's say for example, kini siya, di ba mo ni acid and this one is the base. So let's say for example, this is a strong acid, a very strong acid kani. So after siya mo release, nga muhatag siya og proton anhi sa base, ang nabilin kani siya is a weak conjugate base. Weak ni siya kay strong man ni si acid. Okay? And then the same principle and vice versa. Okay, kung si base pod strong, okay, mo form pod siya og weak nga conjugate acid. Okay, so I have here a series of example of conjugate acid and conjugate base. So we have here a conjugate base nga hydronium, okay, hydronium ion. So after siya muhatag mo release og hydrogen, it can form water. O we have a water, muhatag siya na pod og hydrogen, it can form hydroxide ion. Okay. So si sulfuric acid mohatag siya og isa ka hydrogen, it can form hydrogen sulfate. Okay. The same principle applies to the rest. Okay. So please excuse me for a while, ha. Give me a minute. All right. Next. Okay, we have here water as an acid, 'di ba? Water is amphiprotic. Okay, so duha ang iyahang uh, ability, okay, to uh, accept or to donate a proton. Okay. So arita sa water as an acid. Okay, unsa na ito kung acid? Kung acid siya, siya ang mo release, siya ang mo hatag og proton. Okay. So in this illustration, ang ato ang base is si ammonia. Okay? And then atong acid si water. Water act as an acid here. So during the reaction, okay, the hydrogen, okay, si hydrogen, ma-release siya, okay, towards ammonia. Okay, so unsa na may nabilin? Kinakuhaan man si water og isa ka hydrogen. Nabilin is OH, isa na lang ka hydrogen. Unya, ang ning dawat si base. Nya, what happened to base? Nahimong NH4 plus. Kinahimo siyang ammonium. Okay, so ang ning dawat, okay, mao na gitawag na to og conjugate base. Nya ang ning dawat conjugate, I mean ang ning hatag, okay, ang ning hatag mao na atong tawgon nga conjugate base. Unya ang gihatagan mao atong tawag conjugate acid. Okay. So I hope na clear na siya. Okay, take note ha that water act as an acid in this example. Okay, how about if si water mo act as a base? So meaning to say si water ang mudawat. Okay, so what will happen? So we have here an acid which is a hyaluronic acid. Okay, a hyaluronic acid which reacts with water. So in this case, si water madugangan og hydrogen. Okay? So duha ka hydrogen atom na dugangan og isa nahimong tulo. So from water it forms hydronium. Okay, you can have H3O plus, okay, which is an ion. So ang nabilin kanina lang si A. Okay? Ang gihatagan, okay, ang gihatagan si kani, okay, ang tawag ani is conjugate base. Kanya ang nabilin, ang tawag is conjugate, uh, ang gihatagan, ang tawag, conjugate acid, unya ang nabilin, conjugate base. Okay. I hope that's clear. Alright. So, I have here exercise for you to understand the process. So, what is the conjugate base of nitric acid? Example, this one. Okay. Conjugate base kuno sa nitric acid. So, meaning to say, kini siya kuhaan na to og hydrogen. Kay ang conjugate base, di ba, kay bilin. So, asa may makuha ani si hydrogen. So, unsa may nabilin kung kuhaan na to og hydrogen, isa ka atom, nabilin si nitrate. O nabilin si nitrate. Our answer for this is nitrate or NO3. Okay, how about this one? What is the conjugate acid of cyanide? Okay, so ug mayon tag conjugate acid, hatagan. So kay gihatagan man ni siya, so ato rang dugangan og isa ka hydrogen atom. So mahimo siyang HCN. Okay, so unsa may ngan ana? Hydrogen cyanide. Okay, hydrogen cyanide. Nga na siya. Alright, how about this one? We have bicarbonate ion. So si bicarbonate ion is amphiprotic. Okay, amphiprotic, pwede siya muhatag, pwede siya mo dawat. So ari sa ta sa muhatag. Let's say for example, ni-release siya og hydrogen. Okay, mo-release ni siya og hydrogen. Unsa may iyahang conjugate acid. Unsa may iyahang conjugate acid. I mean, muhatag og muhatag siya ang ato ang form is conjugate base. Ari sa ta sa mudawat, I mean. So let's say for example, kini siya si bicarbonate mudawat og hydrogen. What is our conjugate acid? O dugangan na ninimo og isa ka hydrogen atom. So you can have H2CO₃, which is carbonic acid. Okay, our conjugate acid for bicarbonate is carbonic acid. Okay, and our conjugate base is, kuhaan ni nimo siya og hydrogen atom, isa, nabilin si CO3, 2, which is a conjugate base and it's called carbonate. Okay, ang tawag is carbonate. Okay, very good. All right. So lastly, let's talk about the pH concept. What is pH concept? When you say pH concept, it's about the measurement of acidity. Okay, how acidic is a substance. Okay, relative amounts of hydrogen ion and hydroxide ion in aqueous solution is expressed in the pH scale. So if you try to look at the pH scale, it ranges from 0 to 14. So ang 0 is the most acidic. Unya, ug moabot ka sa 7, that's the neutral. And then kung moabot ka sa peak, the 14, mo na pinaka basic. So 0 most acidic, 7 is neutral, and then si 14 is most basic. Okay, so a logarithmic scale is used to simplify the numbers since the range of concentration is so large. Okay, if we try to measure the range of concentration, okay, or the acidity or basicity of a substance, dako siya og scale. Scale. Kay daghan kayong substance. However, to simplify that, okay, we break that down to this scale. Okay, mo na nga, ang range niya is 0 to 40. Okay, so this is a graph, okay, or an illustration about the pH. Si human blood, duol-duol ra siya sa neutral.